Welcome to HP Tuner's Ford Gen 2 Coyote Training Part 17. This training module, we're going to be taking a look at working with our MAF Tuning Basics, what we need to absolutely know in order to get started dialing in our mass airflow sensor and how this fits into our airflow model. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at the basics of our mass airflow sensor, understanding how it functions, how it works, how it plays a role in fuel, spark, torque, and variable cam calculations. We're going to be taking a look at how we prep our calibration file for dialing in the mass airflow curve and the importance of setting everything up properly. We're not going to be diving into, in this tutorial, how to actually tune the mass airflow curve. We're going to be looking at that in a separate tutorial. We want to make sure that the file is prepped and we understand what is going on in the importance of the mass airflow sensor. So this video is going to be really critical and just dialing in anything for your Gen 2 Coyote. So if you're having, let's just say, weird spark timing problems, or if you're having fueling problems, or if your torque calculations are off or something seems off, a lot of it boils down to an incorrectly dialed in MAF curve. So very important. It's very basic concept here with the MAF curve, but very, very important because it's extremely powerful. It's probably the second most important sensor that's fitted to the engine. The most important sensors would be the cam and crank sensors. Those determine the engine position so we can fire the coils and the spark plugs at the correct time within the auto cycle. After those signals, the mass airflow sensor is the very next important signal. So we want to make sure this is calibrated right, and it's relatively straightforward to do so, but there are some things we need to know about this to make sure we're doing this all properly. So let's jump into this tutorial, and we're first going to be working in a calibration file here that I've read out of the vehicle. This is our test vehicle for our training course. It's a 2017 Mustang GT, so I've read the stock equivalent file out of the vehicle, and we're going to be modifying it. So that's what I have open on my screen right now. We can see I've labeled this just MAF Basics. I've just renamed the file so I have something that I can just go back to or pinpoint when I'm filming these tutorials. So that's what I've saved this file name as. You can open up any calibration file, 2015 to 2017 is not going to matter. Even a GT350 file, if you have a GT350, it'll be fine to follow along. All of the information I'm going to be talking about here in the tutorial is going to be applicable for any of our Gen 2 Coyotes. So let's jump in. Let's take a look at this calibration file. Let's find out where we can source the MAF curve and then talk about what we need to do and what we need to know in order to dial in the MAF. So first things first, we're going to go up here into our engine tab, and then we're going to work our way across here. So I'm going to go from general up top here. Now it's a little bit slow to load. I apologize. My laptop might be bogging down here a little bit. Going here from general, going over to airflow, and then in airflow here, we have a specific area under general that's labeled MAF calibration. This is what we're going to be focusing heavily here on in this tutorial. Now, a few things with the mass airflow sensor. Let's talk about how it functions, the importance of the mass airflow sensor here first before we jump into the specific tables and the scalar values here to change some things around in order to put our engine control module into its MAF only mode. The mass airflow sensor is fitted to the intake track or the air box for our engine. It's going to be measuring how much airflow is coming into the engine at any given time. This is going to be telling the engine control module the air mass, which is used in our underlining fuel and airflow model. We've talked about this already. Fuel mass is equal to air mass divided by target air fuel. If we're measuring the air mass, and we know that coming from the mass airflow sensor, and we're specifying what we want our target air fuel to be at based on what our base table or power enrichment, the watt lambda table, is going to be specifying, we can then figure out what the fuel mass should be. We can convert a fuel mass into an injector pulse width based on knowing low and high slope for our injector data and our injector offset or latency values. Put all that together, we can send out injector pulse width, pulse the injector, put the fuel into the engine. If everything is right within our modeling, we'll find that we'll hit the target air fuel that we're requesting. Now, if we're not hitting that target air fuel, let's say we're richer or we're leaner, well, that could either be an issue, we have a fuel modeling problem, we have an error in our fuel injector data, or we have an error in our airflow or air mass modeling. Now, if we've changed the intake assembly, put on an aftermarket intake, we have changed then the mass airflow calibration curve that no longer is going to be accurate that we find here in our tables up at the top here. So our mass airflow versus period table specifically for our Gen 2 Coyotes, that table's not going to be accurate. We need to go and reinitialize that. So when we change out the intake from stock, we flow more air across the mass airflow sensor. We have to account for that. When we're flowing that airflow across the mass airflow sensor, the sensor itself is going to be sending out a digital type signal. It's going to be a pulsing type signal. So as we flow more and more airflow, the
period of time where the pulses happen actually shrink, and if we have less airflow coming over it, the airflow is going to be slower, therefore the pulses will occur more spread apart, and in that case, they'll be able to register that in this lookup table right here. So it's pretty straightforward. Airflow goes over the sensor sends an output, the output will be read from the engine control module. Based on this table right here, it'll do a lookup for that period or the amount of time that pulses are happening in. It'll look up what the airflow is going to be, and from there, it plugs it into the equation. Now, that's going to be for the fuel and airflow model. Spark timing, torque calculations, and variable cam control all hinge upon the mass airflow sensor reading because we have something called engine load that's calculated from knowing the air mass coming into the engine, which is a function of the mass airflow. So all of those tables, and we'll look at that here towards the end of the tutorial, we'll poke into some of those tables.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.